Okay, so in the last video we figured out that suspect alpha at 1:30 was in the library because we were given two different angles, and all we had to do was use our protractor and figure that out. Okay, so we've got that information, we can put that in our table here. So at 1:30 suspect alpha was in the library. Alright, so now let's go through another example that's a little harder. So let's look at suspect alpha again, and let's look at 1:10. So where was suspect alpha at 1:10 is our question. We're given two pieces of information. From tower B, 41.2 degrees west of south, and from tower D, 3623.57 feet away, so 3,623.57 feet away from tower D. Also notice over here I've given you a hint here that says use obtuse. So we immediately know we might be dealing with, or we are dealing with, the ambiguous case of the sign law. So keep that in the back of your mind while we're going through this example. Okay, so tower D and B are given as 4,000 feet apart. The coordinates here are saying where they are. So each distance here is 2,000. This is 2,000. This is 2,000 feet. This is 2,000 feet. So the distance between tower D and tower B is 4,000 feet. Okay? So we're going to get a blank piece of paper and we're going to draw our diagram. Okay? So for suspect alpha at 1:10, we're given tower B 41.2 degrees west of south, tower D 3,623.57 feet away from tower D. All right, and we are given in every single question the distance between the towers. The distance between the towers in this case is 4,000 feet. Okay, so that is always given. So now we are given one direction here, 41.2 degrees west of south from tower B. So we're at tower B, we're going to use our protractor, and we're going to point our direction in this west direction, the 90 degrees in the west direction, okay, from tower B. So, put my marker on tower B, point the 90 degrees in the west direction. This is north, south, east, and west. So I'm pointing in the west direction, and it's 41.2 degrees west of south. So I'm on the south arm here, down here, and I'm going to go 41.2 degrees. Okay, so let's count that. 10, 20, 30, 41, and a little tiny bit, something like that, okay? And I'm just going to extend that line, okay? I'm going to extend that line. Now, I'm given a distance this time, so I'm not sure from tower D, I'm not sure what angle I should measure from tower D. So I don't know, but I know it's somewhere down here on this line, right? I know it's somewhere on this line. So what I'm going to do is just draw a line. It doesn't really matter. I'm unsure of the angle right now, but I am sure of the distance. So it is 3,623.57 feet of this distance, okay? Next thing I'm going to do is I'm going to label my triangle. That's the key when we're doing sine and cosine laws. Label our triangle. So DB, in the past we were labeling this as C because it's a location of the cell phone, but because in this project one of the tower's names is C, I'm going to pick a different variable. I'm going to call the cell phone position E, and I'm going to I will label every single cell phone location in this project as E so I don't get confused with tower C. Okay, so if that's big E, then this is little e. If that's big B, this is little b. If that's big D, then this over here will be little d. Okay, and this was the measured angle, right, of 41 48.2 degrees west of south that we were given. So we can find angle B quite easily from that, right? So we have this whole angle is going to be 90 degrees. So we know that angle B equals 90 degrees minus 41.2 degrees. So that will give us 48.8 degrees for angle B. So we can pencil that in right now. 48.8 degrees. Okay? So we are now have an angle side pair. Angle B and little b. So we know we're going to use the sine law. And we're going to say sine of big B over little b equals. Now we have to pick if we want to do big D and little d or big E and little e. Since we're given this piece of information for E, we're going to use sine of big E over little e. I don't have little d or big D, so I'm not going to use that angle side pair in this equation because I can't solve for anything in that case. Alright? So let's solve for the angle big E, because then we can get big D, which is what we want. Remember from the last video, we need two angles from two different towers to determine the angle, or the position, sorry, of the cell phone, which I've labeled as big E. Okay, so let's find that angle E so we can use the sum of all the angles in the triangle to get angle D. Alright, so isolating for sine of E first, I will have sine E equals little e over small b times sine of big B. Then I will take the inverse sine of both sides to get E by itself. Sine inverse of E over B sine big B. And I just have to put my numbers in. Alright, so sine inverse of little e, which we are given is 4,000 feet. Okay, so 4,000. Little b, which we are given 3623.57. 3623.57 sine of big B, which is 48.8 degrees. 48.8 degrees. Okay, and we're going to type that into our calculator, and we're going to get 56.1582184 degrees. Okay, that's angle E. Alright, but here's where I'd like you to pause, okay? When we started this question, suspect alpha 110, we were told to use the obtuse angle. That means that, okay, we're dealing with the ambiguous case of the sine law here, and I've been given a hint to use the obtuse angle. This angle is not obtuse. That is less than 90 degrees. So what we need to do is we need to find the supplementary angle to E. Okay, so the supplementary angle to E would be 180 degrees minus 56.1582184 degrees, which is going to give us our actual angle E, which is 123.84 degrees. Okay, so that's our actual angle E. Okay, that's angle E. So now we can use the sum of all the angles in the triangle to get angle D, which is what we want. We want that angle from tower D. Okay, so we want this angle from tower D, so we'll go angle E plus angle B plus angle D equals 180. That way we can solve angle D equals 180 degrees minus angle E, 123.84 degrees, minus the one we were given, 48.8 degrees, should give us 7.36 degrees. Okay, so now angle D is 7.36 degrees. So now all we have to do is go to our map and we can put in these two angles with our protractor, and we should be able to measure where suspect alpha is, okay? So, remember on our map, we are here. We just found that suspect alpha at 110 was 7.36 degrees in that triangle, right? So here's D to B, here's that 7.36 degrees, okay? So let's measure 7.36 degrees down this way, okay? So one way to do that is we are going to figure, let's go. This is 90, so 90 plus 7.36 this direction is going to be 97.36 degrees, right? So we want to go 7.36 down that way. So we have 90 plus 5, 6, 7, something like this, okay? Something like that. So we're going to draw and extend our line from D. There we go. Suspect alpha lies somewhere on that line, on the map, okay? And we're also given that angle of 41.2 degrees west of south, okay? So let's just re-measure that on our map. We're going to go 41 point it in the west direction, and then we're at the south arm, 41.2 degrees west of south, 41.2. Now we just draw that line, extend that line from B, and then we have that intersection point right here. So now we know that we have suspect alpha at this point at 1 hour and 10 minutes was really close to the fine arts complex, okay? So let us go to our table here, and all we have to do is put in at 110, suspect alpha was near the fine arts complex. Okay, so you're not just handing this in to me, you will be handing in your map that has your drawn on it and all of your work. So all of the triangles you've drawn on separate pieces of paper, all of your work to figure out your angles, okay? So this work should be saved. This is what you're handing in with your drawn maps and your filled out tables, okay? And then your final answer on the very last page to determine which suspect it is.